Next, in the cosmological perturbation theory, we will look at one point in gauge 1 and gauge 2. Remember that we have seen that gauge 1 and gauge 2 are the perturbed gauges, and so there are three different coordinate systems when we are looking at two perturbed gauges. So there are two perturbed gauges and one is the background universe. So we have the background universe. This is the background universe, and then we have the perturbed gauge 1. This is gauge 1, which is X alpha caret, and then we have gauge 2, which is X alpha tilde. This is gauge 2, and we have seen that X alpha tilde is equal to X alpha caret plus xi alpha, where xi alpha is placed on the background universe, and hence xi alpha is xi alpha expressed in terms of X alpha. Now today we are going to analyze a scenario, a very important scenario, and this is very important. That's why I am dedicating one video only for this scenario, and that scenario is 1 point. So we have 1 point P. If I take 1 point P, one fixed location in the four-dimensional space-time. So that point P in gauge 1 is having coordinates X alpha caret. In gauge, in the background universe, it is having coordinates X alpha P, and in gauge 2 it is having coordinates X alpha tilde P, and all these three coordinates are different. So this gauge 1 is perturbed gauge, meaning its coordinate system is slightly different from the coordinate system of the background universe, and hence this is not equal. Gauge 2 is also slightly different from the background universe, and hence this is not equal. And we have also seen that X alpha tilde minus X alpha caret is xi alpha, and hence X alpha caret is also not same as X alpha tilde. So this is not same as X alpha caret P. So all the three coordinates are different at one given point. So this is very important to understand, that at one given point the three coordinates are different. Now we need to look at, so when we take this 1 point scenario, first thing that we look at is coordinates. So we see that the coordinates are not the same. So 1 point, coordinates are not the same. Now take a scalar quantity, a scalar field F. F at P, when we evaluate F at point P, this F at point P is same in gauge 1, same in the background universe, same in gauge 2. So this is the same. The value remains the same. For a scalar field F, the value in the three coordinate system remains the same. Fp remains the same, whether I evaluate this in gauge 1 or in the background universe or in gauge 2. Now if I take F alpha vector. So first was coordinates, second we looked at scalar, third we are looking at vector, a vector field F alpha. A vector field F alpha, when we evaluate its value at point P, it will be different in different gauges, in different coordinate system. So F alpha P will be different. And any arbitrary tensor which is not a scalar, so if I take for example F alpha beta, they all at one point P. So this is our scenario. We are taking one fixed point P in the four-dimensional space-time. So in the one fixed location in the four-dimensional space-time, when we evaluate these tensors, their values will be different in different coordinate systems. So this is what we are evaluating, that how do these values change from one coordinate system to another coordinate system. Coordinates do change, we have seen. Scalar remains the same. F alpha P will be different in different coordinate system. So scalar remains the same in all coordinate systems. So F alpha P is different in each coordinate system, or you can say different in different coordinate systems, value is different in different coordinate systems, and tensor again different in different coordinate systems. Then why do I say this? Is it something new that we are learning in this perturbation theory? The answer is no. This is this scalar, vector, tensor, when I am evaluating in different coordinate systems, I am borrowing the knowledge from what we have seen in the theory of general relativity. So in general relativity, we have seen that any arbitrary tensor, for example, I have this tensor F alpha beta. I will just give you one example, and more we will discuss later in the course. Let me give you one example. Let's say I have this F alpha beta at one given point P. So if I say that F alpha beta at one given point P engage let's say engage 2. This is engage 2, let's say. And let me say that this is F alpha beta engage 2. Let me decorate the indices with alpha tilde. And don't worry about the notation, because we are going to come back to this in detail later in the course. Right now I am just giving you some basic idea that if I have this F alpha tilde, beta tilde evaluating at one point P, and again I want to know the relationship with F alpha caret, beta caret evaluating at point P. So this is gauge 1. And then there is something called transformation matrices, which we will see later. I can write this as X alpha caret, alpha tilde, beta caret, beta tilde, F alpha caret, beta caret. Whereas X alpha caret, alpha tilde is delta X alpha caret over delta X alpha tilde. And don't worry too much about this expression or the notation, because we are going to look at it again. but this is something which we have seen in the theory of general relativity, that at one given point P, this is how we transform a tensor. And if it is a scalar, then the value of scalar remains the same. Whether I am looking at it in gauge 1 in one coordinate system or in another coordinate system, value of scalar remains the same. And tensors transform according to this relationship. X. Yeah, so we'll come back to it, but this is what we have seen in the theory of general relativity. So the idea is that when we are evaluating the value of fields at one given point, coordinates do change. And because that's how we are defining our perturbed gauges. Perturbed gauges are variation in coordinates from the background universe, and each variation is unique. So each gauge is different from another gauge. That's how we have this first expression. Then the scalar value at the same point. So remember, again, I am emphasizing same point, one point. I am taking one point. I am evaluating this at the same point, because there is going to be another scenario which I am going to talk later, and in that scenario we will not be seeing these values at the same point, but we will be seeing them at the same set of coordinates. Let's defer that discussion to one of the next videos. But in this video, we want to know that when we are at the same point, at one given point, fixed location in the four-dimensional space-time, that's how the values of fields change. Scalar field does not change. Vector field and tensor fields, they do change according to what we have seen in the theory of general relativity. Thank you.